Good day everyone. For today's video lesson, we will tackle about pre-calculus conic section, which is all about parabola. So this is our third conic section. So before we tackle the equations, what are the ways to solve for the equation, we need to first identify what are the different properties of the said parabola. We call it properties and sometimes we call it parts. So for a parabola, remember these are the most important parts that is being used to solve for its equation and how to graph it. The first one is called the directrix and the focus. Remember that a parabola is set of all points in a plane that are equidistant from the fixed line, which is called the directrix, and the fixed point, which is not on the line, which is called focus. Remember, the fixed point should not be found on our fixed line. So from the definition, we can see here that it is said that set of all points in a plane that are equidistant. Same with the circle, all of the points in the circle are equidistant from the center. But in this case, the points on the parabola is equidistant to our fixed point and fixed line. So for example, we put a point here in this part of our parabola. It is said that it is equidistant to your focus and also equidistant to your directrix. If this is 5 units, this is also 5 units. So that is how we come up with our parabola. Without the focus and directrix, we cannot form our parabola. Before we proceed to the next property, remember that the distance from the vertex to the focus or vertex to the directrix is equal to c units. The c units will help us to determine the opening of the parabola, if it is a parabola that opens upward, downward, left, or right, if we would try to solve or identify what equation is being given. And remember, if vertex to focus is c units and focus to the directrix, vertex to the directrix is c units, if we add the distance, focus to directrix is equal to 2c units. So twice the distance between the vertex and the focus. Continuing to our next property, we have what we call the midpoint between the focus and the vertex. Kanina nabanggit ko na yung distance between the vertex and the focus is c units. Remember, midpoint po siya, meaning that the distance between the focus and directrix, and if you get the middle part, it is still your vertex. And as we remember, vertex is the farthest point or the extreme points of the parabola, hyperbola, and ellipse. So dito makita natin that the parabola has an extreme point. It can be the lowest point or the highest point for a parabola that opens down and up, and the farthest point if the parabola will open left or right. Including on the slide is the axis of symmetry, that is a line passing through the focus and the vertex. Remember, the axis of symmetry is used to identify if the left side and the right side of the parabola are equal to each other or symmetric, as stated on its name. Axis of symmetry defines that if 2 points are given that are having same positions on the Cartesian plane on our um, y-axis. So for example, here, point A and another point here on the opposite side, point B. Axis of symmetry gives us equal distances. So if this is 6 units, the other side also gives us another 6 units. As I mentioned earlier, this axis of symmetry is a line that divides the parabola into two equal parts. So equal meaning the distance between 2 points that are on the left side or right side. For example, here, point A, and on the opposite side is point B. To check if they are along on the axis or on our y-axis, we would check the distance to the axis of symmetry. Okay, this is 6 units again. This is also 6 units. Okay, that's how an axis of symmetry works. And our last property is called the latus rectum. That is a line segment. So remember, this is the third line that we have, but the difference between the latus rectum and the first two, which is the directrix and the axis of symmetry, latus rectum is a line segment. It passes through your focus, just like the axis of symmetry, but it is parallel to your directrix. And it also has the endpoints on the parabola. So it is a line segment. So those endpoints are called the endpoints of the latus rectum that will be included on the properties that we need to find as we go along on our lesson. So there are few things that you need to be reminded about the latus rectum. First one is it is a line segment, just that I've mentioned. It connects 2 points on the parabola that are called the ends of the latus rectum, and it passes through your focus, parallel to the directrix. And lastly, the length of the latus rectum, since it is a line segment, is equal to 4c units. So we need to find this later on, and it would very much help us to determine our parabola. So aside from this commonly known property for the latus rectum or characteristic, it also dictates how wide or narrow your parabola is. If the value of the length of the latus rectum is larger or longer, therefore your parabola becomes wider. And if it is shorter, so the parabola will become narrower. And you are very curious on what is the meaning of the latus rectum, because the word rectum is commonly used in the digestive system part of the biology subject that you have, right? So the latus rectum has many, is a Latin word that has two definitions. So we can see on the next slide that the word latus rectum is derived from the Latin word latus, which means line, and the rectum, which means opening. So it is a line opening, just I've mentioned to you, that it dictates how wide or narrow your parabola is. And also, it is being defined as side and rectum meaning straight. So straight side or straight line. So just like we have on the diagram, it is a line passing through your focus. So that's all for our video presentation. These are all the properties we need to identify as we go along on our topic on parabola. Remember, tell me I forget, teach me and I may remember, but involve me and I will learn. Mathematics is not a memorization subject. It is a subject that you need to practice for you to answer the different problems that we are encountering.